So starting off with, so this is just a recap of everything that we've done. So it's all about right-angled triangles and the fact that if two right-angled triangles are similar, the same shape, different sizes, then all of the angles will be the same. So for example, everything in the big triangle is the same shape as everything in the small triangle. It's just the big triangle has been scaled up. So 3 divided by 6 is 0.5 because the 6 is twice as big as the 3. And then in the big triangle, you can see that the corresponding side, 15, is twice as big as the other corresponding side, 7.5. So you can see that it's the same shape because the ratios or the relationships between any two pairs of sides are the same. Because of that, we know that if that's 30 degrees there, then the big triangle must be 30 degrees in the same place as well. Whoa, no. And in fact, if it's a 30-degree triangle, that will always be the case. So any 30-degree triangle will always have that same property. So it could be 10,000 there, and then the other one, the hypotenuse, will be twice as big, 20,000. Whenever it's 30 degrees, then the hypotenuse is always twice as big as the opposite side. So just reminding ourselves what these three sides are called. The longest one is the hypotenuse. The one that's opposite the angle is called the opposite. And the one that's next to the angle but isn't the hypotenuse is called the adjacent. Adjacent just means next to. So hyp, op, adj for short. Hypotenuse, adjacent, and opposite. We saw that the opposite divided by the hypotenuse will always be a half if it's a 30-degree triangle. And you call that relationship sine. Sine of the angle is the opposite side divided by the hypotenuse. So in this, what have we got here? Sine of, just showing you how to do it on your calculator, sine of 30. I'm pretending to click on these buttons, but really it's just all been set up before. Equals, pretend to click on equals, is 0.5. There's actually 3 of those, as you know, sine, cos and tan. Sine is what you get if you do opposite divided by hypotenuse. Cos is what you get from adjacent over hypotenuse, short for cosine. And tan is what you get from opposite over adjacent. So depending on what information you have in the problem, you decide whether to use sine, cos or tan. So it was sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, tan equals opposite over adjacent. Can you remember any ways to remember those? You can just try and remember it as a word, SOHCAHTOA. I always find that quite difficult, and I always used to have silly old Hitler caused almighty havoc to our armies as a way of remembering it. There it is. So there's an exam question. In triangle PQR, angle Q equals 90, so it's a right angle triangle, so we can use trigonometry. Angle R equals 37, QR equals 12.6, so the side Q to R 12.6. Calculate the length of PR. Well, what is PR? Is it the adjacent, the hypotenuse, or the opposite? The hypotenuse because it's the longest one. What is QR? Is it the adjacent or the opposite? Adjacent. It's the adjacent because it's next to the angle and it's not the hypotenuse. So in relation to that 37, 12.6 is the adjacent, and the thing we're trying to find out is the hypotenuse. So if we've got adjacent and hypotenuse, what do we use? Sine, cos or tan? Cos equals adjacent over hypotenuse. So putting in everything we know, cos of 37 equals 12.6 divided by PR. Cos of 37 you can work out on your calculator, 0.7986, and some more numbers which you can just keep in your calculator. We don't like fractions, so get rid of that divide by PR by multiplying both sides by PR to get 0.7896 times PR equals the 12.6 on its own. We want to know what the PR bit on its own is. So we'll have to divide by the 7986 to find out what PR is. So PR is 12.6 divided by 0.7986, which you can do on your calculator, and it comes to 15.03. And just go back to the diagram and check that that makes sense. That kind of looks reasonable enough that that should be 15.03. Right, so that was where we find the missing sides, but sometimes we have to do it backwards and find the missing angles. So, for example, PQR is a right angle triangle. PQ is 11 centimeters. So from P to Q is 11 centimeters, and QR is 24 centimeters. So from Q to R, 24 centimeters. Calculate the size of the angle PRQ. That means starting at P, going to R, and finishing up at Q. So it's that angle in there with R in the middle. So in relation to that angle, have we got the opposite or the adjacent or the hypotenuse, or which ones of those have we got? Here.
Opposite and adjacent.
11 is the opposite in relation to that angle, and 24 is the adjacent in relation to that angle. So there's the angle. 11 is opposite, 24 is adjacent. And if we've got opposite and adjacent, is it sine, cos, or tan? Yep,
Tan.
it's tan. So tan equals opposite over adjacent. So whatever that angle is, the tan of it is 11 divided by 24, because it's the opposite over the adjacent. So that's different from having to find out the tan of 11 over 24. We're not going to find out tan of 11 over 24. We need to find out what number, when we do the tan of it, will give us the answer 11 over 24. So that's not quite the same. So on the calculator, I will do something like, again, I'm going to pretend to be pressing the buttons here, but really it's all set up before. So, I've got to do that first. So PRQ is the inverse tan of 11 over 24, so that we get the answer 11 over 24 when we do the tan of it. Right, so on a calculator like this one, it will be shift tan to get the inverse tan, and then open the bracket to do 11 over 24. So open a bracket, and then 11 divided by 24, close the bracket, will give us the inverse tan of 11 over 24. So that little -1 there tells us that it's the inverse tan, or the arctan. And we had to press that shift button or second function button before the tan button to get that. And that comes to, press equals, 24.62. So the inverse tan of 11 over 24 is 24.62. In other words, that angle there is 24.62. So that's your final answer, 24.62. Oh, exam questions. Right, the idea with this is that when you look at this at home, you pause the film now, try and do the question, and then the answer comes up, and then you can pause it again and check the answer. Smart, yeah. And that's the end of that PowerPoint. And that's the end of my little